Hello there, Mr. Sutton here, bringing you the Pre-Cal Honors 4-4 Extra Practice number 3, Part 1 solutions. This one has a riddle that goes with it. Let's go ahead and check that out. So this is the first of two puzzles that are actually on the same page. We're only covering the first puzzle in this video. There's another video for the other puzzle. So for this one, we're trying to figure out what kind of music do mathematicians listen to. And the idea here is they've given us a bunch of expressions to simplify using both laws of exponents and laws of logarithms. Once we figure out which letter has the answer choice that goes with whatever we're simplifying, we just have to put that letter down below in the box that has the number we just did. So, for example, let's say I do number 1 and I come up with answer choice, I don't know, E, whatever. It's probably not it. But let's say that was the answer choice. Then I would put an E in box number 1 down below. And I keep going until I've filled in all the boxes. So let's see what kind of music mathematicians do listen to. For our opening question, we're trying to simplify e to the x times e to the negative x. Since I have the same base that I'm multiplying, I can do that by just adding the exponents. That's one of my rules. So we've got e to the x plus negative x. That's going to be e to the 0. And anything to the 0 power is going to be 1. So that's going to be A right there going in box number 1. For number 2, we've got e to the x to the 3rd. Now when I'm raising one power to another, I'm really multiplying the powers. So this is really going to be e to the 3 times x, or 3x. And looking for that in my answers here, I see that in choice N. So that's going in box number 2 down here. For this next one, we have e to the x divided by e to the negative x. Since I'm dividing the bases, I'm subtracting the exponents. So this is e to the x minus negative x, which is really e to the x plus x, or 2x. E to the 2x is right here. That's h. So h is going in spot 3. But be careful, there's actually another spot 3 right here. That's one of the few duplicates, but they do exist on this. So 2h is there. For this one, I'm multiplying the bases, so I'm adding the exponents. We have e to the 3x plus negative 4x. That's really going to be e to the negative x. And e to the negative x is g right there, so that's going in spot 4. For number 5, we're taking a logarithm and simplifying it. So ln of e, this is natural log of e. That means log base e of e. So I'm basically asking e to the what power equals whatever's inside here, e. Well, e to the 1 equals e. So that one is just going to be 1, choice A. So that's going in spot 5 right here. On this one, I'm asking e to the what power equals 1. Well, e to the 0 equals 1 because anything to the 0 equals 1. So we have 0 for this. 0 is d, so that's going in spot 6 there. For number 7, I want to know e to the what power equals e squared. Well, e to the 2 equals e to the 2. So that means we're going with answer choice y going in spot 7, which is right here. For number 8, I'm taking the ln of 1 over e. So I'm asking e to the what power equals 1 over e. And to get that, I need a negative exponent, specifically negative 1 would give me this. So negative 1 is here, b. So that's going in box 8. For number 9, I'm taking the ln of the square root of e. So I'm asking e to the what power equals square root of e. And with radicals, you need fractional exponents. The denominator is going to match whatever your radical index is, in this case 2. The numerator of the fraction is going to be whatever the stuff inside is being raised to. So in this case, we have e to the 1 divided by 2, 1/2. And 1/2 is going to be the same as 0.5. There's a 0.5 right here. That's O. So we'll put that in spot 9. For this one, I want to know what I have to raise e to in order to get e to the x. Well, that would be x. Do I have an x down here for answer choices? I do. Choice L. So L is going in box 10. For 11, I'm raising e to the ln of x. Now, the key to this one is realizing that the ln of x is the thing I need to raise e to in order to get x. So whatever that thing is, if I take e and raise it to that thing, I should end up actually getting x. Another way to think about it is e and ln cancel out. So this is just going to be x, which is L, which is going in spot 11. For number 12, I'm taking the ln of 32. Now 32 is not a power of e, so I can't really simplify this in the traditional way. What I can do, however, to match one of these answer choices, because I don't just see ln of 32 written anywhere, is I can rewrite this as a power of something and then pop out whatever the exponent is. So 32, I can write that as a power of 2, 2 to the 5th power. And then if I pop out that 5 as a coefficient using my laws of logarithms, so that's going to be 5 ln of 2 then. And that's going to be choice R, which I'm going to put now in spot number 12. For 13, I've got e to the x times 1 minus e to the negative x. To make my life a little easier, I'm going to distribute that e to the x first and see what happens. So e to the x times 1 is e to the x. E to the x times negative e to the negative x. Well, I'm adding the exponents there. So that would be a negative e to the 0 power. And I can rewrite e to the 0 as just 1, because anything to the 0 is 1. So we have e to the x minus 1. That matches u, so I'm putting u in spot 13. For 14, I'm taking 1 plus e to the x and dividing all of that by e to the x. So I'm going to divide these each individually by e to the x, kind of distributing my e to the x division here. And then I'm just going to rewrite these. I can rewrite 1 over e to the x as e to the negative x, just using a negative exponent. Typically I wouldn't do that, but I'm trying to match an answer choice, so I'll do whatever it takes. And then we have e to the x divided by itself. That's just 1, so plus 1. E to the negative x plus 1 is t right here, so that's 14. For this one, we have ln of 2 plus ln of 3. The only thing I can do to simplify this is merge these into one logarithm by multiplying the things inside the logs. So this can really be rewritten as ln of 2 times 3, or ln of 6. ln of 6 is going to be right here, that's s, so 15 is s. For number 16, I can simplify this expression by merging these into a single log, and I can do that by dividing the stuff inside since I'm subtracting the logs. So this is really ln of 12 divided by 2, or ln of 6, which is still s based on what we saw in number 15. So 16 then is also an s. For this one, I've got ln of x to the 5th minus ln of x to the 4th. I can merge these into a single log by dividing the things inside. So this is really ln of x to the 5th divided by x to the 4th. This is just x in here if I subtract the exponents. So this is just ln of x. And ln of x is going to be right here. That's m, so that's 17. So here we are on the final problem. I can simplify this expression by multiplying the arguments inside since I'm adding the logs. So this is going to be ln of e to the 5th plus negative 7. So this is e to the negative 2 in there then. And then if I just take the ln of this, I'm asking what do I have to raise e to get e to the negative 2? Well, that would be negative 2. Another way to do this is you could have simplified this in the very beginning to 5 plus negative 7, which is also negative 2. So that ends up being e right there, so that's going in spot 18. And now at this point I filled in all of my missing letters. I'm ready to solve this riddle. What kind of music do mathematicians listen to? And it's all separated out nicely here, so I can just read it off. Logarithms and blues, right? Like rhythms and blues. So until next time, Mr. Sutton signing off.